All right. There's empty seats. So questions. How's Zenity looking? Yeah.
When we're working on Zenity, can we do like one form box instead of a whole bunch of one after the other boxes?
So some versions of Zenity allude to a form option.
Yes.
I have yet to see somebody successfully use that.
Yeah.
So I would say plan on doing it sort of piecemeal. But if you find that it works, go for it. But yeah, it seems to be either obsolete or not built in or something. So I've had a few people install Zenity under Cygwin, and they report that by following those instructions, it does still work under Windows. So that should be a good option. Yeah.
So about PE4,
Mm-hmm.
I'm wondering how to use the test file to test my program.
How to use a test file to test your program.
Yes, how to.
So in general, any program that will read from standard in, if you just type program name less than test file, it'll run your program, but it'll read from the file instead of standard in.
Yeah. So do you have a test file available somewhere online? How to put that into
You can use the test file that was listed in the assignment.
Yes, I don't know how to
Just copy and paste it into a file.
copy and paste.
Yeah, that's the easiest way. And I used a variety of other test files, and I also used War and Peace. But I mean, you can just type some text and count how many times each phrase occurs and run it into your program and see if it gives you the same answer. Mm-hmm. So we'll go through the details of PA4 tomorrow. But if I could grade your program, I graded it and left you feedback. And a number of people nailed it 100%, worked perfectly. A number of people, it worked perfectly except on War and Peace, and that's, a hard test because it stresses the bounds checking and all that kind of stuff. So that's awesome too. By and large, the programs that were successful were the ones that broke the problem into, a hierarchy of functions. Not just breaking it into different pieces to break it into pieces, but, having a main program that calls the phrase reader and have the phrase reader call your super get car and have your get car call the regular get car and sort of building up a hierarchy like that. The reason for doing that is really to simplify your task of coding, right? So that, your main program assumes there's a function that gives it a phrase and assumes there's a function that saves a phrase and tallies it, and then it just calls those in a loop, right? And your phrase reader assumes there's a function that gives it a nicely pre-processed character. But I saw a lot of solutions where the main program was calling super duper get car and then trying to build up a phrase and then trying to do something with spaces and then saving it in the dictionary and at the same time trying to decide if it was a unique phrase and also trying to sort it. And this was all inside main, right? And you can make that work. That's really complex to try to do, right? So for most people, right, breaking things into smaller pieces makes it easier so that this piece of code I'm writing is only doing one thing, right? And the way that you can write a piece of code that only does one thing is to push the other things into other pieces of code, right? And this is like the difference between assembly language programming like in Engineering 270 or programming in C. If every time that you wanted to print something on your display, you had to take your number and change it into a bunch of digits, right, and send those to an output device and all this kind of stuff, right? So we just call printf, and anytime we want to display a number, we just say printf %d, comma, number, and we don't worry about the details of that, or if we want to read something from the user, or if we want to calculate a square root, right? And that's the real purpose of having functions in your programming environment, is to take these behaviors and just bundle them up in something and say, hey, do this thing for me, do that thing for me. And so the code that you're writing, right, you can do exactly the same thing. Break it down into these pieces and just throw those into other modules. All right, so I do want to talk more about makefiles, because most people seem to have a lot of difficulty with makefiles. So it's called makefile, not makefile.c. Okay, a number of people call their makefile.c or .txt. It's really just makefile, because when you say make, right, make is a command, and what the command does is it looks for a file called makefile, and if it finds it, it will read what's in there and do things accordingly. So call your file makefile, uppercase or lowercase m, and it's pairs of lines, right? First line says, here's what I want to build, here's what the dependencies are. Second line says, if those dependencies are satisfied, here's how you build it. And that second line has to start with a tab. 8 spaces does not work. Okay, it actually cares that it's a tab character. So if I want to build main, maybe I need main.c and sort.c and print.c. And if I have all of those, right, that could be my command for building main. That's a perfectly functional makefile. Yeah?
So, is it required to have a header file with the functions in it in the makefile?
No.
You don't have to?
No. The makefile does not care what you're doing, right? It doesn't know anything about C or compiling or header files or anything else. It simply knows, here's something that you want to build called main. Here's some files that need to be up to date in order to do it, and if those are up to date, here's a command I should execute. Now, if you have, something like functions.h, I would go ahead and put that here, so that if you change function.h, it will say, oh, function.h is newer than main, I'm going to go ahead and re-execute that GCC command. But if you don't have a .h file, that's totally fine. And if you only have a single main.c, right, this is perfectly legit. Alright, so if I say make, it goes ahead and it makes main. And if you say make again, it tells you it's up to date. And then if you edit main.c and you say make, then it'll redo the GCC. So if you did just a single file, right, that's all your makefile has to be. But it can be a lot more than that also. And I think a lot of people tried to use one of the sample makefiles that we had used up here in class and tried to force that to work with their code, and that's not going to work. I mean, if I was using 5 .c files and you've only got 2 .c files, then you need to just use 2 .c files, right? That was really just an example. But I want you to understand what this stuff means, right? All right, so let's talk more about regular expressions. So we were talking about searching, and we had things like anchors and periods for wildcards and stars for repeated occurrences of something, and things inside brackets or things inside bracket with a hat to negate them, and so on and so forth. And I think we started talking about ways to do substitutions that were more interesting than just replace X with Y. So let's make a file. So suppose I wanted to swap the first two characters on this line. Let's make this more interesting. Suppose we want to swap the first two characters. So I know I can search for the first character by saying caret followed by a period, and I can find the second character by putting another period. So if I search for a pattern which is caret period period, right? This period will match the first character. This period will match the second character. And what I'd really like to do is substitute that with the second character followed by the first character. So here's what you can do with these regular expressions. You can put parentheses around something. And when you have a pattern in parentheses, anything that matches that pattern goes into what's called a register. It's a temporary holding area. And so this first character gets saved in register 1. And the second character gets saved in register 2. So this is substitute slash. Here's what we're looking for. We're looking for the beginning of a line followed by anything else. That first anything, because it's in parentheses, it gets saved in register 1. The second anything gets saved in register 2. Now this is a substitute command. If I were to just say substitute caret dot dot slash slash, right, on the first 10 lines, it's just going to replace those first two characters with nothing. It's going to basically delete them. Right, so the effect is just to do that. What I'd really like to do is replace those first two characters with the contents of register 2 followed by the contents of register 1. Okay, so to get the contents of a register, you can say \2 \1. So \2 means contents of register 2, and \1 means contents of register 1. So if I substitute caret parentheses dot slash \2 \1, that should swap the first two characters. There's one additional detail. Normally when you have a parenthesis, it just means the character left parenthesis, the character right parenthesis. So to use these parentheses to throw things into registers, you need to \slash them. So this is actually going to look like substitute caret \paren dot \close paren \paren dot \close paren slash \2 \1 slash. And you got to know how to write it because it's almost impossible to read. Okay, so we're really just doing caret dot dot, throwing parentheses around them, but it's always a \slash parenthesis. So up here, just think of it as being in parentheses. So now if I say, let's just go through the first time, 10 lines, substitute \paren dot with \2 \1, it swaps the first two characters with each other. Okay, so let's pick on names. So suppose I want to change this to first initial period space last name. So how do we find the first name that we want to replace with the first initial followed by a period? Beginning of line, any succession of characters followed by a space. And this is greedy. It will match as much as it can of this pattern. So if there was a space over here, it would match everything up through and including that space. Since I'm assuming it's just a name, space, name, this pattern will match JOHN and the space. Okay, and I want to replace that with just the first initial followed by a period. Well, I don't have a piece of this pattern that matched just the first initial. I have a pattern that matched everything in the first name. So let me change this slightly. Let's match the first character followed by any succession of characters followed by a space. And let's throw this first character in parentheses. And let's replace that with \1. That's the contents of register 1 followed by a period followed by a space. And remember, there's backslashes on the parentheses, but that makes it even more unreadable. So find the beginning of the line followed by any character followed by any number of characters followed by a space, and just replace that with that first character followed by a period followed by a space. Alright, beginning of line, parentheses, dot, close parentheses, any collection of characters, space, replace with \1 period, space. I should change John's to J dot, Barney to B dot, Betty to B dot, and so on and so forth. Is this making any sense? Yeah.
The asterisk for like any number of characters. Why doesn't it just work with just an asterisk? Why does it have to be a dot asterisk?
Because asterisk means 0 or more occurrences of the previous thing.
Okay.
I don't know if it will work with just an asterisk. Let's see. Interesting. I don't know what it's doing there. That's very strange. I think the asterisk without a dot before it is really wild carding. Maybe. I don't know, I've never tried it like that. I don't know what it's doing. So I'm thinking of this dot asterisk as basically a wild card that matches 0 or more characters in a row. And I'm using this dot because that's the thing I actually want to throw into register 1. But if you do the asterisk right after that, I don't know what it's trying to match. That's weird. So if we have a name that has a middle name thrown in the middle, is this pattern still going to work? Same pattern we've been doing. And the answer is yes, because greps are greedy. Okay, so on this first line, we're looking for the beginning of the line, that's right before the J, followed by any one character, that's the letter J, followed by any collection of characters, followed by a space. That pattern, that dot star space, should absorb OHN space, HENRY space. It should match as much as it possibly can. And yeah, just going up through OHN and this space, that does match that pattern. It's a collection of characters followed by a space. But it can match an even bigger pattern if it really says this OHN space HENRY matches the dot star. It's a collection of characters followed by this space. So grep will always try to match the largest pattern possible, which means all of this is going to match the dot star. This J is going to match the first dot, which gets thrown into register 1. And so that should just get changed. All of this should get changed into J period space. I'm really glad it did that.
So if there's a space after the name, this one doesn't work.
If there's a what?
There's a space after the family name.
Yes, so if there was a space out here, so then the dot star would match the entire rest of the string, and that first line will just turn into J period space. Alright, so you're right. So how would we get rid of spaces at the end of all of this? Suppose we knew that some of these lines had extra spaces. This happens a fair amount. And I can say :set list, and VI will show me where each line actually ends. And so you can say, oh, there's spaces on the end. So how could we get rid of extra spaces at the end of a line? Hint, using a regular expression. Say it again. I liked it. $ space star. So space star will match a collection of 0 or more spaces, right, which would pick up all those extra things. I would make one change to this. I would put the $ at the end, because $ really says this has to be the end of the string. So if you do space star $, that says any collection of spaces followed by the end of the string. And that should be perfect. So $1 substitute space star $ with nothing. You ready for this? Bang. Perfect. So substitute space star $$ slash. So that wipes out trailing spaces. Good. Okay, so what if you wanted to go what if you want to change first name space last name into last name comma space first name? And I can't tell you an algorithm for doing these. They come with practice, but I'm embarrassed to tell you how much practice I've had on these.
I'm thinking you could put the dot and then and less space in the first register one.
Okay.
And then all of them in the register one and equal space.
Okay.
Yeah, and then for the second one you put space first and then wait, there's and then dot.
Mm-hmm.
And then the star.
Cool.
Yeah, all of them.
Okay.
And then replace the by register 2. Yeah.
Cool. All right. I like that. The one issue I see with that is that right now it's going to look for 2 spaces in the middle. And it's probably not going to find those if there's only 1 space here. So I probably want to get rid of one of these. But that's a minor detail. Other than that, does this make sense? So what's happening at a higher level? We're really grabbing the first name and throwing it into register 1, and we're grabbing this last name and throwing it into register 2. And once we have those, then we can print it out as, last name comma first name, or just last name, or any other variation we want. So here's a slightly simpler version. Right, we can match the first name into register 1, followed by a space, followed by the last name into register 2. And replace that with register 2, comma, space, register 1. And the space is really just what we're using to break up the first name from the last name. So let's see what that does. So bunch of stuff, space, bunch of stuff gets replaced with second stuff, comma, space, first stuff. And on that first line, bunch of stuff followed by space should match John Henry. So that'll be register 1. So that should be Smith, comma, John Henry, and everything else should be fine. You ready? Perfect. Now, we didn't use anchors in there, and we didn't need anchors because it's greedy. It's going to try to match as much as possible. But it never hurts to throw in anchors if you really want to start at the beginning and end at the end. But it'll always try to find as much stuff to match as possible.
Would you include the anchors in the parentheses, or would they be outside if you're doing it that way?
I think you can do it either way with that. I usually put them outside, but I think it works fine if you put them inside. Yeah, that's fine. All right, how can we get rid of middle names?
You store the middle name to register and then not use it.
Okay. Okay, what would that look like?
Be pretty similar to that expression that we have. You just have another star dot space. Or dot, yeah, dot star space.
Like that. And then if we just want to get rid of the middle name, we could just replace this with \1, \3. I think that would work. I didn't do a $sign, but I don't think it matters. So replace first, second, and third names with the first name and the third name. Perfect.
Do you need to put the middle name into a register?
You don't. We could just match the first and third, throw them into registers, replace it with 1 and 3. There's also a way we could do this without any registers at all. There's usually a lot of ways to do these things. Can you think how to do it without using registers?
We want to get rid of the middle name, the middle name is already there.
I undid it.
Isn't that?
That's what it turned into. Yeah.
Space, dot, star, space.
Yeah.
And then just with nothing.
Cool. So if there's a middle name, then there's 2 spaces in the name. Otherwise, there's only 1. So if we substitute space followed by any collection of stuff followed by a space with, well, probably with a single space, right? That dot star in the middle is the middle name. We get rid of that and the space after it. All right, that should also take out the middle names. Starting to get the idea? All right. So these just take practice. They're puzzles. The more you mess with them, the quicker it is to come up with these solutions. But it's really just using this very small set of pieces for regular expressions, right? Periods, asterisks, throwing things into registers, anchors for beginning and end. You don't need a whole lot else. So grep is a utility that will search for patterns inside files, and it understands regular expressions. So if you want to search for something in a file, you can use grep. So if I want to search for the word yellow inside this file called foods, I can just grep yellow foods, and it shows me all my lines that have yellow anywhere inside them. So I can say grep for a space followed by anything followed by a space inside my names file. I think I have spaces on the end. Yep. Okay, I can search for a space followed by anything followed by a space inside my names file, and it shows me my lines in that file that had a middle name. Yeah?
So whatever you're looking for with grep needs double quotes.
Say again?
Whatever you're looking for with grep needs double quotes.
Not necessarily, but in this case, bash interprets asterisk specially. Right? Remember, if I say ls star, that star gets replaced with all the file names in my file. So dot star is getting replaced by anything in my directory that's a period followed by anything, which in this case is the directory dot dot. And so it searches for that inside my names. So double quotes is safe, right, or single quotes. Plus, since I wanted spaces in there, right, if I just have spaces without quotation marks, it just thinks it's separating one part of the command line from another. So usually you throw it inside quotes. We can also reverse what grep does, and we can say grep-v, and that shows me lines that don't match the pattern. So grep-v, same thing, would show me all the names that don't have a middle name. So it's those other three. And you can also do grep-i, and that says ignore uppercase, lowercase. Grep has about 1 million other options to it, but those are the only ones I've ever used, -i or -v. Doesn't mean the other ones aren't useful. And grep's pretty fast. And it works on binary files, it works on readable files, it works on all sorts of stuff. Let's see if we have a network connection. It's been touch and go today. So there's all the phrases from War and Peace, first 1,000 of them. If I pipe into a grep-i war, I can find all the phrases that have the word war anywhere inside them, which is surprisingly few for something called War and Peace. I wonder how many have peace. Even fewer. Should have been called Lots of War and Little Peace. And some of these, it found war inside the word downwards. But if I really wanted the word war, I could try searching for space war. But if war was the last thing on the line and ended with a period, it might not catch that. Like those. And it won't catch it if it's the first thing in the phrase, but that's hard. Well, I guess I could search for less than war. So grep is useful if you have a lot of output from a file, from a program, and you're looking for something like maybe an error message, or maybe something that indicates success or some condition has occurred. Grep's a nice, quick way to search for things.
So for the first search, you just search war. So it means it will come out with all the sentences with which kind of war in the sentence.
Mm-hmm.
I mean, what about
Yeah, so like this one. And so it found this sentence that said, you know, but I warned you, because it had WAR in there. I'm going to have to read this someday. Yeah.
Can you do like ors and ands in the grep to kind of narrow stuff down?
A little bit. So ands you can just do by multiple greps, right? I can search for war, and I can also search those results for, you know, off. And so it'll find the one where you say off to war. And you can do a little bit of right, if I want to search for like anything containing a Q or a T, I can put those inside brackets, and that'll give me lines that contain a Q or a T anywhere in them. Not a lot of Q's. So who and but. I don't know of an easy way to. I don't think you can trick it like this. Yeah. I don't know of an easy way to or in one line like that. But we're going to start talking about sed and off, which is going to like give us a whole programming language on top of regular expressions. And then we'll be able to do things like searching for this or that pretty easily. So let me give you a really simple example of sed. I'm on the server. All right, so we have these regular expressions, for example, for changing this into first name period last name, right? Okay, so I can go into VI and I can say :1, $, substitute / blah blah blah. So sed is the stream editor. It basically lets us do VI-like things on standard in and send the output to standard out. So I can type sed quote substitute slash caret, one character, any number of characters followed by a space with backslash one period slash, and I can say let's just process the file names, and it'll go ahead and apply that substitution to each line of the input file and then send the result to standard out. Right, or I can have it read standard in if I don't give it a file name, and if I'm just redirecting standard in from here, it will read it from names. Or if I just do this, right, it'll just read from standard in, apply that substitution, send the output to standard out. So this is one way to use sed. It's a way to just basically apply substitutions like what you would do in VI to standard in. And that's useful. And if I have a command generating output that I want to edit, I can just pipe that into sed with a pipe, put in a regular expression that I want to modulate the output, and it will do it on the fly. All right, so we'll start talking about sed in detail tomorrow. And that'll be a whole programming environment that we'll talk about, and then that will lead us into talking about awk. We'll also talk about PA4 tomorrow.